Today I'm going to show you how to fill in your notes about the different ways to represent a function. You're going to need this copy of the notes, your ISN or Interactive Student Notebook, some scissors, and some tape. To begin, you're going to take the notes and fold the sides in so that it has a booklet with 4 sections on the outside. You're going to take scissors and cut flaps into the front. So that you have 4 little doors that can open on the inside. When it's done, you should be able to open these. You'll see set of ordered pairs matches this. When you open here, you should be able to see input-output table, coordinate plane, you'll see it at the top, and mapping diagram, you'll see it right here. So next you're going to fill these in and tape them into your notebook. The first section we're going to fill in is set of ordered pairs. This is the first way we're going to talk about how to write a function. So ordered pairs, the whole set is written inside curly brackets. So this is the start of my set, and this is the end of my set. Each ordered pair is separated from the next with a comma. So let's start with -3, 2. I'm kind of just making these up as I go along. -4, 4, 2, 1, 6, 1, -1, 5, and 0, 2. Each set of ordered pairs has an x coordinate and a y coordinate. The x coordinate comes first and the y coordinate comes second. We'll see what this means at the bottom. So below you'll see coordinate plane. Pause the video here if you need to write these down. And we're going to graph these ordered pairs on the coordinate plane. The coordinate plane is another way of representing the same function. So you'll notice the first coordinate in the coordinates, the first digit in the coordinates tells us our x value, and the second one tells us our y value. So the x coordinate tells you how far to move left or right, and the y coordinate tells you how far to move up or down. Our x-axis is the horizontal axis that goes side to side, and the y-axis is the axis that goes up and down. Usually in algebra, you're going to receive coordinate planes that are not numbered like this one, so you're going to have to kind of figure it out on your own. So we'll begin with our first coordinate, -3, 2. You always graph x first, so I'm going to count back 3, 1, 2, 3, and up 2. That'll be my first point. Next, I have -4, 4. Two, 1, 1, 2 to the right, up 1, 6, 1. That's actually not going to fit, so I'm going to change it. We'll change that to 5. So 5, 1 will be my next. 1, 2, 3, 4, 5, 1. -1, 5. -1, 1, 2, 3, 4, 5. And finally 0, 2. 0, you just don't move left or right at all, and then you move up 2. So that's all of my points graphed on a coordinate plane. The next way to represent these same points is an input-output table. There are 2 ways you're going to see tables. Sometimes you'll see them vertically, and sometimes you'll see them horizontally. It's important to know where x and y go on this table. So the input is always x, and the output is always y. X is your input, y is your output. In a vertical table, they are set up like this, and in a horizontal table, it's set up like this. So take a moment to transfer your ordered pairs from here into the table here. Remember, in general, your x values are going to go in order. So for x and y, we'll start with our lowest x value. So that would be -4, then -3, -1, 0, 2, and 5. You'll notice the same pattern happens in the horizontal table. It's just a different way of representing it. So these values are going to go across. -4, -3, -1, 0, 2, 5. And they all have the same outputs. And that's an input-output table, the third way to represent a function or a relation. Last is a mapping diagram, and this might be one that you have never seen before. All of your inputs are going to go in the first oval, and all of your outputs are going to go in the second oval, as you can see here. You don't repeat any inputs, and you don't repeat any outputs. So let's start by getting all of our inputs here with no repeats. I can just transfer it down from my table. And now I need my outputs to go here with no repeats. It doesn't say that it has to go in order, but often the mapping diagram does go in order. So my smallest output is 1, and even though there are 2 1s, I'm not going to repeat it in the diagram. Then I have 2, and again, even though there are 2 2s for my output, I'm only going to put 1 in the table. 4 and 5. At this point, you might be kind of confused because there's no way that we connect which input goes with which output. That's where this part comes in. An arrow is drawn from each input value to its corresponding output value. So -4 had an output of 4, so we're going to connect with an arrow like this. -3 went with 2, so we'll get an arrow going this way. -1 goes with 5. 0 goes with 2. It's okay to have 2 arrows going to the same number. 2 went with 1. And finally, also 5 went with 1. Now you can see that it's kind of not the best diagram, because honestly, all of these arrows can start to look a little bit confusing, but this is the correct way to diagram our mapping. And now you have 4 different ways of representing the same function. You have a set of ordered pairs, a coordinate plane, an input-output table, and a mapping diagram. And these 4 different ways of representing the function are exactly equivalent, so each and every one of them is just a different way of representing the same information. Now, this is going to go in our notebooks in the next available page, which is going to be page 17. So you'll add page 17, the date, and then probably the best way to tape this in will be to put rolls of tape on the back corners and tape it in that way. And of course, don't forget to update your table of contents with this information as well. You can call this representations of functions. Also, if you'd like to, we are starting Unit 2 now, so you can put a line here that separates Unit 1 and Unit 2. So now you know this is the second quarter, like this was on the first progress check, and this will be on the second progress check. All right.